Awesome. Well, welcome back everybody to day four of Intro to Coding. We are going to pick off from where we left off yesterday. Let me go ahead and start sharing my screen now. A quick disclaimer, I am still very sick. At this point of my sickness, I have a cough, so I will try to mute my mic every single time that I might cough. So if I do slip one by accident, I do apologize. So I just want to give that disclaimer. And to reiterate for those of you who are seeing this recording from home, tomorrow at 6 p.m. Central Time, at the start of class, we will have the instructor from um, the pre-work who is in charge of the live technical assessment for the course. He will be showing up tomorrow to, well, not tomorrow, I'm sorry. He'll be showing up Wednesday to speak to every single one of you guys about the live technical interview process. Yeah, sorry, John, I misspoke. Wednesday. So he'll show up and he's gonna answer any questions you guys might have. Like, what are you looking for during the interview? What you'll be working on. Why would somebody fail? What does your ideal candidate look like? Stuff like that. But really. I just want to make sure that you guys understand that we're not looking to fail anybody. We just want to make sure that you have a certain level of understanding of what you are doing, right? And the reason for that is it's not because we're just looking for the best of the best, but really it's because the our programs, um, it's a fire hose of information, right? So there's a lot that you have to learn in such a short time that we want to make sure that the people who are coming through are going to be successful, and not, get to like week four and they're like, I can't keep up. This is too much for me, right? Maybe I did not prepare as much as I did. So he'll answer all those questions. He'll also tell you that even if you do fail the first time you come around, that does not mean that you're not allowed to reapply, right? And retry for, I believe you should be able to try out for the same program again or for a future cohort if you need that, more time to ensure that you're ready, right? So we've had people retake the live technical assessment multiple times because they just, you know, weren't ready. They had a lot going on in life, whether it's children, responsibilities at work, deaths in the family. They just couldn't dedicate themselves to ensure they, had that baseline of knowledge, and that's okay. But we don't, blacklist nobody. You guys show up. If you guys aren't ready yet, that's fine. You can reapply, and that's okay. But he'll answer any of those questions for you guys. I also want to once again drop the attendance form real quick in the chat. So take 30 seconds to fill that out for me.
And
And
if you were to fail the live assessment, do you have to start the application process all over, or are you able to just retake that part?
that's a very, very good question. And I am like 70% sure you just have to retake that part. They kind of would just like defer you to another cohort, like, okay, well, you didn't pass this one, but you can, apply for this incoming cohort later on once you're ready again. And then you just reschedule another appointment. I'm pretty sure it's that way. If you've already made that point, you don't have to do it. So I'm sure he'll tell you the same. But he'll answer those questions on Wednesday, 6 p.m. But all right. So over the weekend, I've had a couple students reach out, ask questions about the exercises, which is awesome. I love answering those questions. Um, if I ever can't get to you guys and schedule a Zoom call, then typically what I'll do is I'll ask for um, what you call it, a code snippet, like send me a screenshot, and then I will do my best to kind of give you my explanation of it, via text if I'm like in a situation where I can't respond. So do reach out and I'll get to you guys back as soon as I can. This weekend was Father's Day, so I apologize for those of you guys that did reach out and I wasn't able to get to you guys so quickly. But I am here to answer your questions. Additionally, some questions that came up were, where should I be in the program right now? I've been watching the recordings, I've been doing I've been showing up. What should my progress be right now? Ideally, you want to have already completed all the exercises for lessons 1 through 3. Now, if that's not your case, that's okay. There's nothing wrong with that, right? That's the good thing about the fact that you guys are doing this course 2 months in advance, that you have this buffer time to learn and take your time, or a decent amount of time on these exercises. You asked Dante here, who's taking part of previous courses. This course used to be taught like a week prior to the application process, so it was like a time crunch, and it was very difficult. But right now, you guys are in a good spot. So even if you're not exactly there just yet, it doesn't necessarily mean that you are behind. You're going at your right, at your specific pace, and that's okay. But if you want to know what's a very, very good position to be at, ideally you want to have all the exercises of everything we covered up to this point, right? Um, you know, if we have class on Monday, hopefully by Wednesday you complete the exercise for Monday already, because it's been about 48 hours since then, give or take. Um, I understand Wednesday and Thursday are back to back, so ideally, hopefully by Monday, the exercises for those two lessons are complete. But if not, that's okay. So today we're gonna pick off from where we left off yesterday. I'm sorry, not yesterday. Thursday. And Thursday we finished ordered data structures. Today we're going to tackle unordered data structures. And this is a very important lesson. All right, it's going to cover one of the things that is going to be expected for you to know during your live technical assessment. Now, I've said this before, in other situations, and I'll say it again. The things that we're going to be looking for is variable assignment and reassignment. We've done that since day one, right? Creating a variable, giving it a value, and then changing the value later on, right? Super simple. The next one is going to be lists, accessing, right, and modifying lists. We covered that Thursday, right? So you know how to create lists, how to access different parts of that list using index notation, and how to modify it using appending, dot pop, or extending, right? We covered those methods. The next big topic that we're going to be covering is dictionaries, how to create them, how to access them, and how to modify them, right? So this is another key component that you need to understand before you take the lab technical assessment, because chances are the problem that's going to be administered to you during your lab technical assessment is going to require you to use a data structure like a list or a dictionary. Both of these have their pros and their cons, right? As you guys go through this course, you might be asking yourself, well, Roger, you're teaching us all these different concepts, but when do I know which one to use? It's really going to be dependent on the question, right? The problem, and how you wish to solve it. Could you use a list instead of a dictionary to solve a question? Absolutely. There'll be pros and cons to both of them, but both could probably work in your scenario. It's going to dictate what you're looking for. And then also lists and dictionaries have pros and cons to like how efficient they work. So there's no right or wrong answer, as I mentioned to you guys before. As long as you're able to come up with a solution, that's really what we care about right now. But knowing how to access lists and dictionaries are going to be very important. So without further ado, let's go ahead and get started. The first one we'll cover here for our data structures uh, for unordered. It's not going to be dictionaries right off the bat. We're going to be covering sets. Sets are a mutable, unordered collection of unique elements. And it's important to know that these are unordered, right? Unlike the lists that they have in order from index 0, 1, 2, etc., right? Sets don't have a specific order. So whenever you put items into a set or a dictionary, they're not going to have a specific sequence that they'll come out every single time. Now, what you may notice when we run them here, they'll come through. Sometimes the dictionary will look ordered, and if you run it enough times, sometimes you'll see that the order is going to change. Um, I know some people have brought up the fact that with the new updates of Python, dictionaries have become ordered dictionaries. Uh, there's a lot of technicality with how it's working under the hood. Um, the only thing I have to say in regards to whether a dictionary is ordered or unordered, just don't rely on it to be ordered, right? I would not use it as if like you're expecting one value to be at this position, the next value should be at this position. It's not always a very reliable data structure to use when thinking about positions. So take that how you will. So
So
it's that
your apologies. You're saying sets, but you're also saying a dictionary. Are they used, those phrases used interchangeably or?
that's a great question. Sets and dictionaries are two different things. They're both unordered data structures, and they both have unique methods that you can use with them. The biggest differences between a set and a dictionary is how the values are set into each other. And you're going to see this key difference very quickly here, right? So to create a set, there's two ways of creating it. One, which is the least common way, and you saw this method very recently with lists. You call the keyword of sets with some open and closed parentheses, right? You saw that yesterday with the list creation. As you see here, the list can be called and created using a list method, not common at all. And the same thing could be said with the set. Uh, you don't usually create sets too often using the set keyword, but it exists. So I'm showing you that this is a way in the event you come upon it. So this will create an empty set, right? Essentially, it's going to create some kind of data structure that allows you to save values into it. Um, the difference between this and a list is that it's not ordered, right? The first item you put in here isn't specifically at index 0, right? If you add a second value, when you call this, the order might be switched. If you add a third value, everything might be arranged again, right? Rearranged. So keep that in mind. Sets are not ordered, so you cannot rely on these to give you a sequence. Now, what differentiates this from something like a list is also how they are created. So if you want to create an empty set, you would use the set keyword. And we see here, needs a kernel. Uh, it prints out a set, nothing crazy. I could probably even do type. And if I run this, it'll probably give me the set type. Yeah, it gave me the set type, right? So you can see this is a type of set. But normally, when you do create a set, you're going to have values in them, right? This is a more common way of doing it. And to differentiate between a set and a list, it's going to be the brackets that are going to be to the left and to the right of it, right? Lists use square brackets, where sets use curly braces, right? Or curly brackets, whatever you want to call them. All right, these are little squiggly brackets to the left and to the right. And then the values, just like lists, are separated with comma values. So this tells me that there's 5 different items within this set. Now, before I move forward, I want to answer Myra's question here. She said, "You're using the word set in the dictionary. How do I know what's the difference?" Well, once we continue with this class, you're going to see dictionaries. And dictionaries, I'll show you real quickly. Dictionaries are going to look very similar to sets. Notice that the dictionary, this is a dictionary here, it has curly braces as well. The difference between a set and a dictionary is that a dictionary takes key value pairs, where a set takes individual items. Once again, it takes key value pairs. So the first item in a dictionary is going to have a key and a value, right? This is one pair. Where a set, it doesn't have key value pairs. It has individual unique values in each position, right? So sets and dictionaries are both unordered data structures. They can both hold values in no specific order. The biggest difference between a set and a dictionary is how the values are stored in them, which is sets have individual values and dictionaries have key value pairs. But we will get down to that road in a little bit, Myra, talking about dictionaries. It's just, I wanted to show you that now because you did ask. Yes.
Thank you. No question. So the box at the top has has my underscore set equals set with regular parentheses. Are those supposed to be curly, or is it okay that it's not?
So that's a good question, right? You're wondering, like, well, Roger, you said sets are supposed to be distinguished with curly braces. So this is a function. This is a function that's going to return to you an empty set, right? That's why it has parentheses, because it's a function, it's a pre-built function in Python that's going to create an empty set for you. And the reason why it's important to know that you can create an empty set this way is because if you try to say my set is equal to open and close parentheses, what do you think this is going to create? It's going to create a dictionary. Watch, let me show you. Yes. So, it's going to get an error here. Let me print both of these out. So on the top here, I'm creating an empty set using this function keyword. And here, I'm going to try to create an empty set by not passing any values. I'm going to use curly braces, and then I'm going to print it out. And you see here, the first one, it did create for me a set. The second one created a dictionary. So because there's two different data structures that use curly braces, Python needed a way to interpret which one will I create by default if you try to just use curly braces with no values. It needed to know what it should be. They both use curly braces. There's no values in them. And as we said, the difference between sets and dictionaries is that one holds key value pairs and one holds individual values. But because we don't have that in here to differentiate them with, Python needed something to default to in the event there is no values. And by default, Python is going to create an empty dictionary if you use just curly braces. So to be able to create an empty set as well, Python has a keyword to create the empty set. That way it knows how to create one without having to do this. Does that make sense? That's why to create empty set, there's a specific keyword for it. Or for the dictionary, we can just use the curly braces because this will default to a dictionary. So both of these data structures use curly braces. So we needed a way to differentiate them. Make sense? That's a very good question.
Thank you.
So here we see the my set again. It has 1, 2, 3, 4, 5. So the beauty of the sets, and this is probably the most powerful thing about sets and why people might use them. And really, this is the only reason I've ever really used sets, is because they deduplicate values, right? Sets keep unique values within them, right? So unlike a list that I could probably have a list of like 20 integers of the number 1, if I try to do that with a set, it's going to deduplicate the values, and my set will only have one occurrence of 1. And we can see that here. We have the sets. Notice that there's repeated values. The 1 is twice. We have 2, A, 3, 4, B. And then we see another 1, right? That's the third one we see. We have 5, 7. Here's our second A. So there's duplicates of what seems to be the A's and the 1s, right? This is a set because I know it's a set because it has curly braces, but it has individual values, right? I know it's not a dictionary because it does not have key value pairs, right? So that's how I know this is a set and not a dictionary. And I also know it's not a list because it uses curly braces, right? Here we have a tuple. We covered this last week on Thursday. A tuple uses parentheses, and it's used for values that shouldn't be changed, right? Think about grid coordinates. Grid coordinates don't change. But when we print this out, notice that the tuple has the same values that the set does. The difference between both of these is that the set has that unique interaction where it's going to deduplicate any values. And we see that here that we have 1, 2, 3, 4, 5, 6, 7, B, Y, A. So there is no repeated values within any word inside of this set. Unlike the tuple didn't change. It kept exactly what I passed in there, even the duplicate values. So this is the difference between a set compared to something like using a list or a tuple. A list and a tuple will keep the duplicated values, or a set is going to deduplicate it. So it's only unique values. Right. So now you're starting to see the differences between all these data structures. Right. Lists hold multiple values of different data types and they can hold duplicates. Also, it's an ordered data structure. Tuples hold multiple values of different data types, right? They could be duplicates, but it can't be changed, right? That's the uniqueness to a tuple. Sets have unique values, right? They can hold multiple value types, right? Uh, but you cannot, and you are able to change them, unlike a tuple. So they all have their own individual differences and what makes them unique, right? So you might ask, well, when would I want to use one or the other? At the end of the day, it's going to come down to you and what type of data you're working with. If you know that you shouldn't have repeated characters in some kind of string or a data type, then a set might be a good way to use that. All right. So some unique methods that uh, are given to the sets is going to be the add method, and this is the first one we've seen. So when working with sets, if you want to add something into your set, you're going to use the dot add keyword, and you're going to pass in the value that you're trying to add into your set. It is an unordered data structure, so that's why you don't have methods like dot inserts. If you guys recall, the list had the dot insert method, which allowed you to add a value at a specific index. We don't see those methods here in the set because it is an unordered data structure. So we use the dot add method, which is going to add something to it. If you want to remove a method, you're going to just call the dot remove and then pass in the value. You don't have to specify where this value is at. It's because, for one, it's a unique data structure, so there's no duplicate. So if you try to remove the one, there's only one value to remove, right? Which is going to be that 1, 1. So it also doesn't take positions, right? Because we don't have order to this. So this will remove that specific value, or you can also use the dot pop method, right? Which is similar to the list, right? But unlike the list will either remove the last value in its list using the dot pop method, or you can even specify which value you want to remove with index. Um, the set doesn't do that. It's going to remove a random item in that set because it is an unordered data structure, right? But just like the list, it's also going to allow you to return that value and save it, right? If you guys recall that, the differences between using dot remove or dot pop and list, when you remove an element from a list, you no longer have access to it. It just disappears. But if you wanted to grab that value you just removed and save it somewhere else, you could use the dot pop method, right? That's just a little refresher from what we covered last week. So we have that list here from above, right? This is what we have here. We're going to invoke the dot add method and we're going to pass in 500. And we see here 500 is passed. And it tries to kind of organize it, right? You can kind of see here 1, 2, 3, 4, 5, 500, 6, 7. Although it looks formatted here, don't rely on this, right? This is not consistent. And then we can also use the dot remove element right afterwards, and then we remove it, we print it out, and it's no longer present, right? So we can add or remove items from a set.
I have a question about assignment for that.
Sure.
Just like with lists, I learned that we couldn't say like variable equal to, and then give the list structure dot remove to have it assign all in one line. Is the same thing here to where it has to be like a standalone command?
Okay, that is a good question. So you're saying if I were to do 500, comma 6, comma 7, right?
Like if you tried to say A equal my set dot remove, it would say no, you can't perform those two together. You can't do the remove and the assignment at the same time. You would have to create a new set via A, and then you could run the command my A dot remove
Like
and then
this.
call it. Yeah.
So first and foremost, you wouldn't want to do this because this doesn't return anything to you, right? The pop method does, right? This is just going to remove it. So essentially what you're going to be end up doing is saving none into the variable A, right? So even if it does work, you're not going to get any actual information. The A will be equal to none. I've never tried it because I wouldn't want to do it with A. But oh, there's
Yeah,
no value in there. Give me a second.
yeah, no, it was just something I learned with the lesson 3 examples with the museum. I was trying to use the dot remove method to remove the min and save that new list into a variable all in one line, and it said, can't do that. So,
Right. So yeah, so this one for sure won't work. As you see here, it prints out none. Right. I did remove 7, but when I printed out an A, although this did run, there's no purpose in doing this because it won't give me anything in return. As you see here, it saved none into it. What will work is if you use dot pop and then you pass in 7. This will work, right? This method is made to give you something in return, right? And because it's strictly made to do this, this will work and it will save you a value inside of A. Make sense?
yeah.
I already removed it, so let's go ahead and remove 6, and you can see this. Uh, takes no argument. Oh, that's right, it's a random argument. Okay, I removed the 1. Right, it saved the 1 into A, and I was able to print it out. Let's go ahead and add that back in there. My set dot add. We're gonna do 1. I'll run it, and then I'm at 7 back in here. Print my set. I'll make sure I still have everything in here like I need to. Look at this. You see this? The 1 is no longer where it should be at, right? So, like I said, although it looked like it was organized the first time, it is not reliable. It'll give you some false input at first or at times. So this is a prime example of why you don't want to trust the structure of the sets or dictionaries because although it might look like it's neat at first, as you see here, it messed up now. So the dot pop method removes and returns an arbitrary item from the set. You cannot specify an index with pop. And that's what I tried doing earlier because I was so used to using lists. But you have to pass in the pop method empty. It takes no arguments because it is an unordered data structure and is going to remove something and save it to that value. We see that here. I use the dot pop method. It's going to remove a random number. I don't know which one. It's going to save it to item. Then I'm going to print out item and then the current state of my set. And we see here that the first item here, which is item, is 2. And then set no longer has that 2 inside of it. Do I have any questions on the add, remove, or the pop? If you're feeling a little overwhelmed with the set method, I just want to give a quick disclaimer that I rarely use this data structure. It's not a very common data structure to use or need. Um, so don't worry too much about it. The one that's really going to make a big difference is going to be your dictionary. But it's still very important to understand what a set is. So you're aware that this data structure does exist in case you need it. Especially if you find yourself trying to work with some kind of problem that involves for you to remove duplicates. Let's say you have like this problem that's like take this list, parse through it, remove all the duplicates, and return a list with only unique values. It's as simple as wrapping the entire list around the keyword sets, and it'll convert it into a set, therefore removing values that have already appeared. So that's a very simple solution. That used to be one of our coding exercises that we had, and that was usually the solution for it.
If you were to take a set and convert it back into a list after like the example you just gave, would you have to resort it, or would it try to sort it automatically as it creates the list?
You'd have to resort it.
Okay, gotcha.
Alex asked, is a dictionary basically an object from JavaScript? That's a great question. Technically, yes. JSON or JavaScript has two variations of objects. It's like object literal, and I forgot the other term for the object. They combine the term object into two different things. Or in Python, we separate them. In Python, we have dictionary and we have a class object, two different things. But in JSON or JavaScript, they like to convert them together with some very unique names or differences to them. So if you're referring to JSON, Alex, yes, it is. A dictionary is going to be the exact same thing as JSON, where it is key value pairs separated by commas. All right. Python set supports specific mathematical operations. So this is where sets really shine, is where because they have unique the unique attribute to them. We have a couple of operations that we can use. And these operations are best described with this Venn diagram, right? This is something that you guys should be kind of familiar from elementary school, middle school, right? When doing stuff like comparing and contrast, right? Typically, we might be comparing two different things. We'll have item A on the left and item B on the right. Each item will have their own section where you put things that are unique to each other. And then the middle section is where they intersect, where you see similarities between each other, right? So yeah, all right. The way that sets work is going to be with this kind of logic. And here we see a prime example of it. This is going to be the methods that you're going to use for that. So here, our code, we have A dot intersection B, right? The method is dot intersection, which is going to take another set as an argument, right? This is going to check if anything from the B set intersects with any point of the values in A, right? So it's going to return elements that appear in both set A and B. All right, so we can see here a graphical representation of it. It's going to grab two different sets and see what similarities do we have between each other. The next method here is going to be the dot union method, right? This is going to, as the name implies, is going to combine these together. It's going to return an element in either set A or set B, right? So it's pretty much going to get them all together and return to you one big set. This is okay. I mean, not too useful. The intersection is a pretty good one. The next two would be the difference one, right? This shows you left side difference and right side difference. All right, so A dot difference of B can return elements from A that are not in B set, right? We do have examples of that, so I'll wait for that in a bit. So how this works is going to depend on which one is calling which, right? Because A is calling B, we're going to see what items from A are not in B. If you change this up, we'll see items from B that are not in A. So really, it's just the same method. It's just you're changing who is going to call the method and who's checking against who, right? but this allows you to compare and contrast between two different sets to see the differences between them. The next thing is going to be symmetric difference, right? This is going to return elements in set A or set B, but not in both. So really all the unique values from both of these, where none of these are repeated. Now let's see how this works. So here's going to be my set. I'm going to run this to save this to memory, right? Notice how when I created it, this is the pattern I put in here. But when I print it out, we see here that it's not in the pattern that I initially gave it. So once again, reiterating that this is not an ordered data structure. So you shouldn't trust the order of what you put in here. So this is the other set. Let's print out the previous set. So we have my other set. Let's also print out my sets. So we can see both of them here. Print my other set. Right. So here is my set. This is what I originally created earlier on the examples above. And here is that the other set, right? Once again, the order is a little bit off. Now it's actually showing it to me in a somewhat more organized manner, but still not consistent. We see here B before 10, but right, these are different. We see some similarities, 3, 4, 5. We see some differences, right? 500. We have YA on top, but we don't have it on the bottom. So we're going to use it to compare, right? So we're going to say my set dot union of my other set, right? And this is going to show us the values from both of these. And really, we just see what exists on the left side and on the right side. Notice there isn't duplicates, right? We don't have 3 showing up twice. We don't have 4 showing up twice. It's just going to give us each occurrence of which ones exist on both of them. All right. Next is going to be the differences between them. So we know that this is my set, right? We're going to check what difference is on the other set. So what does my set have that does not appear in my other set? So this should return 6, because 6 does not exist in my other set. This should return 1, Y, and A. So 1, 6, A, and Y. Not the same order that I said it, but we see here, these are the 4 items that are currently in my set, but did not appear in my other set, right? So the dot difference method will allow us to check that. And now we check the symmetric difference. So 1, 6, and AY do not appear in my other sets, but we also have 500 and 10, because these are the values in my other set that do not appear in my sets. So the symmetric difference is going to check which values from my set and my other set do not appear in each other. All right. So 2 different ways of checking differences. You can check just for one side or check both of them. Which are all the unique values for both of these, or which is the unique values for one side or another? And the intersection is where we check what appears in both of these, right? So 3, 4, and 5 should come out. We should see 7, and we should see B. So in total of 5 should appear when checking the intersection. And oh, my bad. We changed them up. We changed what my other set was, so now it's different values. And this is gonna be the 3, 4, and A, because we see 3 here, we see 4 right here, and we see the A right here. So this is the difference between both of these. Do you have any questions on these methods and how they work? Awesome. So now let's actually see somewhat of a realistic example of how we could use sets, right? So here we have a data structure, a set of employees, right? It's a long list of employees. Now should there be any multiples in here of employees? No, right? Because we know sets have unique values. So these are the set of employees who still need to complete their annual training, right? I said somewhat realistic, right? Because realistically, you might have two different people named the same. I'm Hispanic, and in my culture, we have a lot of Joses. So you might get like four Joseses, right? So chances are you might have duplicates in people. That's just how we are. It's okay. So I say somewhat realistically because you might encounter duplicates, but this should give us a good idea of how to work with it. So these are all my employees, and then I have a different set that's going to have the completed training list or set of everyone who has completed their annual training. This might be like your sexual harassment training or your cybersecurity training, whatever training it may be. These are the people who have completed, and I need to know who hasn't completed to make sure that they run through the training so we can meet our requirements, right? So I need to know who from my list, my set of employees, have completed it. And to do that, we can use the difference method as we discussed earlier. So I'm gonna grab my list of, or I keep saying list, I'm gonna get my sets of employees, and I'm going to invoke the dot difference method to see who inside of my employee set currently exists inside of my completed training. And I get an error because employees does not, oh, I have to run this, my bad. Run this, and then I can run this. And then it's going to return to me a unique value of everyone who is inside of employees and appears in completed training. Actually, this is giving me something different.
Isn't that giving you who is not
Yeah, you're right.
completed?
I get confused with these. My bad. But you're right, Mario. Thank you for the correction. We see here that we're getting people who are not in completed training. So it's checking the differences. Thank you, Myra. Gold star. You're on top of it. And here's the long list. Jupyter Notebooks is only going to show me so much. You can see here it's telling me output is truncated. I can view it as a scrollable element, and then it allows me to scroll through them because there's a lot of output, and that's okay. But here is a value of everyone that has not completed. I might want to do something like let's say not completed is equal to, and then I'll call this method, and then I can print out not completed. And not only does it grab everyone that has not completed it, but it saves it into another variable, which is going to be a set that I can use later on my code. So I can send emails to everyone to remind them, hey, it's time to complete your cybersecurity training, right? We haven't completed list for loops yet, but I could say something like for employee and not completed, print, good afternoon. We'll say employee. Do not forget your cyber security training. Now, this is a very, very simple way of showing you this. Oh, I'm thinking of JavaScript. My apologies. There we go. Right, and here I have unique messages to each person where I say, good afternoon, Kylie, good afternoon, John, Antoine, Ramona, Felicia, Talon, Kali, so on and so forth. You get the idea. And I'm telling each one of them to complete their cybersecurity training. So what I might do is loop through all my not completed sets, make a email template is equal to this, right? And then what I might do afterwards is write some script that's going to allow me to create an email, right? And then send it out, add this email template to it, right? So there's different ways of how we could do this. And this is one way of doing it, right? That way I can automate this process. Do I have any questions on how we can use that to leverage some kind of, you know, input like this for automation? All right. No other questions. This is gonna be the end for sets. No questions at all.
None at the moment, but I reserve the right to come back and ask.
Absolutely. Okay. Well, before we start our next subject, we are at our 1 hour mark. So let's go ahead and take our 10-minute break. We'll come back at 7:08 and continue with today's class. All right, welcome back, everybody. We're gonna go ahead and pick up from where we left off. So the next thing we're going to cover today is going to be dictionaries. Now, it was brought up recently. Roger, recently I heard that dictionaries in Python are now ordered, which technically that is correct. Now, we are currently on Python version 3.13. Dictionaries became ordered data structures on version 3.7. Now, the reason why we still cover them as if they're unordered data structure is because chances are, wherever you go, their code base might be based off of an older version of Python. So it's very important that you're still aware of this. Everywhere you go, especially if you work for the government, or you work a federal job, typically their technology and what they use takes years before adapting to the newer and improved versions of stuff. So you're typically working with older versions of different frameworks or different versions of different languages. So you need to be very aware that in the event you encounter a language that does not support the concepts that you were taught. So with that in mind, be aware that yes, technically they are now ordered data structures. Just be aware, be careful when utilizing them, especially with the older versions of Python, because you might not be working with a version of Python that's compatible to what you're trying to do. But regardless, typically when accessing dictionaries, we don't really use index notation. So it doesn't really matter, right? Now, what are dictionaries? Dictionaries are another form of data structure. They are mutable, which, as we already know, means that they are able to change, right? So you're able to modify them, right? They are unordered, or at least now they're ordered, collections of key value pairs, right? Which differentiates them from sets, which we already saw. Sets have individual values assigned to them inside of their curly braces, right? This is the biggest difference between sets and dictionaries. The fact that we have key value pairs in dictionaries. All right, unlike sequences, like our lists, which are indexed, dictionaries are accessible by their keys, right? Which can be of any immutable type. The question asked, are these changes documented every time there's a new iteration of Pi, meaning like what you were just talking about with the dictionaries? They are in the documentation for Python. So if you go to Python website, you can see new updates. I'm sure you can probably subscribe to updates from the Python documentation website if that was something that was a huge issue with you. But yeah, I mean, unless you sign up for it or you look for the documentation or keep up with the changes of technologies, you're probably not going to know. But at least now you know. But yes, everything is documented. Stuff like Python, Java, C#, frameworks that you might use like Django, React, what we use. Any changes, updates, patches to different things is typically uploaded on the documentation, right? It is your responsibility to ensure that you're up you are informed of what's changed, right? It's one you might not like it. Some people enjoy the fact that technology is constantly evolving, so you're always finding yourself learning something new. So it's a good and a bad thing, depending how you see it. But it keeps you always learning, which is pretty cool, personally. So dictionaries are accessible by their keys, which can be of any immutable types, right? Strings, numbers, and even tuples can all serve as keys in a dictionary. The values can be of any data type, even with other dictionaries or lists. The thing about keys is they have to also be unique, right? You cannot have multiple of the same key. Why is that? Well, because that's what we use to access them. Think about a list, right? There's not supposed to be more than one specific item in an index, because one index belongs to one value, right? Same thing like one address belongs to one house, one mailbox belongs to one residence, right? You guys have your own social security number that belongs to one person. These are all what we use to identify, uh, the relationship here. So because we use keys to access these values, each key has to be unique, right? Each key would point to one other different value, right? Monica, are you waving? All
Oh,
right,
there was just a mosquito.
that's okay. But yeah, so dictionaries share many properties with sets. Both sets and dictionaries are unordered, as you already explained the unordered portion. Both sets and dictionaries are wrapped in curly braces. Once again, which is why it's important that if you want to create an empty set, you have to use the set keyword, because by default, if you use empty curly braces, Python is going to assume that you are referencing an empty dictionary. So be aware of that. Sets must have unique entries, and dictionaries must have unique keys, right? So a really good example of when a data structure like a dictionary can be used to collect data for something would be something like someone's driver's license or identification, right? Looking at this image here, we see a lot of key value pairs, right? Starting off with the license number. The key here will be the license number keyword, right? Lic NO, and the value would be the license number itself. The next key value pair will be DOB for date of birth, where the value will probably end up being a string for the date of birth. Expiration date, EXP, will be the key, with the string of the date being the expiration date. And let's see how that would look like. We would say, I'm sorry, did you say something, JJ? Are you okay with calling you JJ? I don't know your first name. Okay, I'm assuming hot mic. That's okay. No biggie. So let's go ahead and create an example of this driver license. So I'm gonna say driver's license is going to equal to an empty dictionary. When I'm gonna create a dictionary with values in there, typically we want to kind of open it up to make some room for our values. So you want to kind of press enter between them to open up a open and close curly braces. And typically you want to put the values inside of here. When you start doing dictionaries like this, you're putting everything in one line, it can become a little difficult to read. So we want to kind of open them up and then work from top to bottom. Kind of like this, right? If you see the set here, this set has a lot of values in here. So if this was all from left to right, it would have, we'd have to scroll from left to right to see the values. So it's common to see data structures to be put on different lines so we can, better read what's in there. That's kind of what we're doing here in this dictionary. We're gonna go ahead and open up this curly braces so we can start adding some context in here. Now, I'm gonna create the license number. It's gonna be a string, right? And I'm gonna give it the value of the license number. Now, there's no data type that I can use except a string for this, right? because we see here we have integers and characters as well as special characters like dashes. So the only way to properly add this as a value will probably be a string itself. So I'll do something like P142 dash 4558 dash 7924. That'll be the first key value pair. The next one here we see is going to be date of birth. So I'll say DOB as a string. And then same thing with the date of birth here. We see the forward slashes. So we might want to just use a string here. So I'll say 11 forward slash 14 forward slash 1987. Is this best practice? Probably not. But I'll explain to you how we can make this better in a bit. Next one we'll see here is going to be expiration. This will be 11/14/2023. Sorry, I'm having to mute myself so I don't cough on the mic. Okay. The next thing I see here seems to be ISS. Once again, another date, 01/01/2019. I don't know what ISS stands for. Oh, issued. My bad. I'm dumb. That's okay. We see here the name. I believe it's public. JNQ might be last name, first name, initial. So I'll say last name. And I'll just keep it all in all caps to stick to the same formatting. This will be public. And then I'll do middle, initial. This will be Q. And then I'll just finish off here with just the first name and we'll end it there. We'll say Jane or first name, Jane. Right? And this is kind of how your key value pairs would look like to represent the data for something like a driver's license. Now, I did mention, this might not be best practice. Why? How could this give me problems in the future?
Doesn't the forward slash means like skip something, or was that the backslash?
Backslash.
Oh, okay.
Why is putting a date that's supposed to be in this format as one whole string could make it a little bit difficult for me in the future?
I think it will make it tougher to access.
Yeah, it'll make it tougher to access, right? What if I want to see the date of birth of somebody? I might want to grab the key of DOB. This will give me the date of birth, but this might not be very readable. I might have to go through here and grab, I might have to split the string apart every single time to know what the month is, to know what the day is. So this might not be the best way of doing this. Which kind of brings me to my next point, is that the values can be any data type, even other dictionaries or lists. Right? So instead of just putting the raw string for the date of birth, I might want to create a dictionary for this specific value in this key. And now we start seeing, I believe, our first occurrence of a nested data structure. I think we saw this very briefly with a list. We saw a list inside of a list, right? So here we're going to put a dictionary inside of a dictionary, right? As I mentioned to you before, the value can be any other data structure. So here, once we get into the key of date of birth, it's going to return to us a value, which is going to be another dictionary in itself. And here we might do something like month with a key of 11 as an integer. And we can then say day with the key of 14 as an integer. And then we can say year with the key of 1487. 1987. I'm struggling today. Right. So this breaks down the string a little bit better in an easier way to digest this and access later in the future, right? Just like Dante said, it might be, it might give me issues on working with it later if it's all consolidated to some string. I would have to break it apart to really understand what part of that string is supposed to be my date of birth. So this here might not be best practice. I could use another dictionary to break it down into smaller components that allow me to know what part is what. Do I have any questions on how we can create a dictionary and how the key value pairs are set in it?
Could you show us how, for example, you would access the year inside of date of birth in that dictionary? So accessing a dictionary in a dictionary.
Absolutely, I can in a little bit. Which actually reminds me, did I ever show you guys how to access a list within a list?
I don't believe so.
Okay.
Yeah, I don't think you did.
Okay, let me do that real quickly. There's a whole class for it, which is why I did it. But just because I'm showing you guys the examples, I want to show you how that would work. I'm going to say list one is equal to 1, 2, 3, 4. And then I'm going to create another list that's going to be 1, 2, 3. And I forgot the equal sign here. So if I wanted to print out list 1 at index 2, this will give me that 3. Index 4 will give me 4. If I say index 5, we see here, oh, did I grab the wrong one? Index 4. Okay, I guess I reached too far out. That's okay. List 1 at index 4, as we see here, what's at index 4? It's a whole other list. When I run this command, what am I doing? I am grabbing a value and using it. So I can say something like individual value is equal to list 1 index 3. And I can print that individual value, right? When I access something in an index, I'm grabbing it, right? This returns something to me, right? I'm not just looking at it. It does actively return something to me. Now, just because it returns it doesn't mean it's going to remove it from the list, but it essentially gives me like a copy of it that I can use and save into a variable, right? So this returns to me the value at index 3, which is 4, and I'm able to save it into a variable, which I can then call and use later. So understand that when you grab an item with an index, it returns it to you. So knowing that, when I say index 4, I'm grabbing the entire list that's at index 4. But because I understand that this is going to return something to me, I know that when this command is ran, this essentially takes up the identity of 1, 2, 3, right? This is going to take the identity of the value that I'm calling for at that specific index. So knowing that, I know that really the identity of this is another list in itself. What I can do is I can chain indexing and say something like index 1. So I can say list 1 at index 4. This is going to return the entire list itself, right? So I know realistically this is actually something like this, right? So what I can do is I can chain an index to specify that I want to grab index 1 that's going to be in index 4 of list 1. And now if I run this, I'm grabbing the 2 that's inside of this specific list, right? So when I run this command, it's going to read this first part right here, and it knows it needs to grab the value that's at index 4. It's going to grab this, and then it's going to read the next part, which is another square bracket, and it's going to say, oh, okay, now that I've gotten the value at index 4, you're saying that you want to grab the value at index 1. This is index 1, right? So that's how it works with lists. Now, keep that in mind, because once we start talking about accessing lists, accessing dictionaries, it's going to come into play as well. But that's how you do it with dictionaries. Now let's continue the dictionary lesson, and when I get to it, Thomas, in a little bit, I'll show you. I just want to make sure that first part is covered so you understand that it's very similar in dictionary. So creating dictionaries, as I showed you, you're going to use the empty curly braces because that's going to default to an empty dictionary. And we do that here. We create an empty dictionary and I assign it to the variable called empty dictionary. When I print that out with the type method wrapped around it, I see here that I get class dict, right, for dictionary. So this will successfully create an empty dictionary for you. Not a set. If you want an empty set, you have to use a set command. Now, here's our first example, besides the one that I showed you, of how we can create dictionaries. Here we have an English-French dictionary with key value pairs. The key is the English word, and the value is the French word. When I run this, it's going to print it out. Hello, bonjour, world, Monday. I think that's what you say. Thank you, merci. I never took mine, so I don't know. Now, how do we access unique or specific key value pairs, Roger? Well, just like we use index notation, or really bracket notation is what we call it. We're going to use bracket notation for dictionaries too, but instead of using the indexes, right? Because the dictionary doesn't necessarily use indexes, we're going to use the key instead, right? And we see that here. Here's a small example of the syntax. You're going to call the dictionary name, and then you're going to open and close some square brackets, and inside the square brackets, you're going to pass in the key. If the key is the string of hello, you're going to type in the string of hello inside of here. This is going to return to you. Pay attention to my verbiage. It's going to return to you the value. So just like you saw on the list, right? That whenever you call something with the index, it's going to return to you the value. That does the same thing here. It's going to access the item and return it to you. So I could call the key of something inside of a dictionary and at the same time assign it to a variable to get it somewhere else, right? Because I know it's going to return it to me. So that's how you access items. Now, how do you update items? Well, you need to know what item you're trying to update. So you want to access it by using the same syntax, the bracket with a key. And after you access it, you're going to change that with the equal sign to specify that you're changing the value. You're reassigning a value to that key. Right? And we see a little code snippet here where we're grabbing the dictionary, the specific key from there, and then we are reassigning a value to what I want. And this is going to set the item at key of whatever that you called to what you gave in as a value.
So can we take the word hello or recall the word hello and reassign it to hola?
Yes. Right. You're correct. So here we have, just like you mentioned, hello, right? We're accessing the hello keyword. And this is a little misleading because it needs a print statement for good measure. We can print out what returns back from accessing a key of hello. But just like you mentioned, could we call the hello key and then give it a new variable? Absolutely. I'm going to say English French dictionary at key of hello. I'm going to say that I'm going to give you the value of hola. And then I'm going to print out the key of hello. And we see here that it gives me hola. So yes, you can either assign a new value the same way you did, or you can reassign an existing value. So right now, there is no key for goodbye, right? We have hello, world, and thank you. But there is no key for goodbye. I'm so sick. I'm sorry. Load. All right. So just like we're able to reassign a value to a key, we can create new key value pairs by calling the dictionary you're trying to access, but instead of passing in an existing key, you're going to just go ahead and just type out what you want to call this key, right? You give it a key name. This one's going to be called goodbye, and you're assigning it the value of au revoir. And now we see here that we have goodbye and au revoir within here, right? So the same way that you reassign an existing key, you can create a new key value pair just by giving it the key and value that you want to create, right? Pretty simple, right? No big difference there. How you access and how you change stays the same. Yes, Myra.
So you just added a new pair to your dictionary.
Correct. The same way that you modify an existing one, you can add a new pair by calling the same command that you did earlier. Just pass in the brand new key that you're trying to create. So the way that you access, I'm sorry, let me rephrase that. The way that you modify and the way that you add new key value pairs is the same way. The only difference is that when you're adding something new, obviously the key doesn't exist. So you're just adding a new key.
So on this block, did this block take into effect block 39? Because shouldn't it say hola instead of hello?
I did it very quickly. You didn't see me, but I scrolled up and I ran the previous block to reassign it back to bonjour. I might have done it a little too fast, but I ran it up real quickly, pressed it so I can get it back to normal to erase what I had done here. But that's a good question. But all right, let's go ahead and move forward. So, hello currently has bonjour back again because I ran it again, right? Let me rerun this. I'm going to rerun the au revoir ones. We have au revoir. Good to go. Right? No changes here. Andrew asked, how do you change the key? You do not, my friend. You remove that key value pair and create a brand new one. So if you go to, because as you saw, right? Well, I can reassign the value of a key and I can create a new key value pair, but how do I change it? I'm not aware. I think actually, I'm gonna take that back. I think there's a method to change the key. I don't use it often. Let me see if there's a built-in method real quick. Nope, you have to remove it. That was correct. Yeah, you have to remove the old key value pair and then create a new key value pair. You don't just override that old one with a new key name. You can override the value, but not the key. All right. So hello only has one string value, which is bonjour. But as you saw earlier on my driver license example, we were able to add other data types as values. And we see that example here again. We have other ways of saying hello in French, right? Bonjour. I believe I'm saying this correctly. Salute. But because we have multiple different ways of saying hello, we need a way that we can separate individual unique values. So you want to create a data structure instead of just a data type, right? It makes more sense if we have multiple different ways of doing things that we create a data structure to hold them all. Because as you saw with the driver's license, the the date of birth was a little bit more complex. We have month, day, and year. If I wanted to access it, every time I access it, I would have to split the string apart to grab a specific value. And that's not very smart, right? That's just creating more work. It's easier if you separate it within its own data structure so you can grab each individual item on its own. And that's kind of what we're doing here. We're going to create a list for a ways of saying hello in French. And they passed in the old bonjour, but this time they added salute. Right, and we see here when we print this out, hello has a key value of bonjour and salute. All right, And now to finally answer Thomas's question, how do we access the different values inside of a data structure that is inside of a value, right? Like we saw on the date of birth of the driver license, right? Date of birth had another dictionary as a value, and this dictionary had key value pairs itself. So here's our first example. We're gonna go ahead and print out the value of the keyword hello. And we know the value of the keyword hello has a list of bonjour and salute, right? This returns to me that list and I can print it out. So what data structure, when I call this command right here, when I run this command right here, it's going to return to me something. What data structure am I now working with?
List.
Is it
A list. Absolutely. So I have to treat it as a list. How do I access a value inside of a list? Using the indexing. So after I run this, this kind of takes up the identity of a list. This is going to equal to this. And if I want to grab salute, I need to treat this as that list. So I'm going to use index notation now instead to grab that specific keyword. So although I initially use a key to grab this value, once that value is returned to me, I'm now working with a list instead of a dictionary. So the next item I add to this chain of code has to be the index. And when I run this returns to me the value at that specific index that's saved to this specific key inside of this specific dictionary, right? So you're essentially just chaining how you're navigating through the structure of this dictionary. Does that make sense?
So if you had multiple lists in that order, you'll be calling list after list after list until the end, you'll be calling the index, right?
Correct.
Okay.
Let's see. Yeah, so if this was, let me give you a hypothetical. Actually, I'll save it to the actual class itself. What's up, Todd?
Question with this, Roger. So referencing this earlier, if we had a dictionary inside of the basically a nested dictionary in this, would we have to when we're calling that up? Would it?
Yeah.
How would we end up working with that?
So going back to my previous example, thank you for asking. Going back to my previous example, I want to grab the value saved into date of birth. So I'm gonna call my dictionary driver's license. And I want the key of date of birth. I run this, and as you see here, I get back the value that's saved there, and it's another dictionary. So I can safely assume that this takes up the identity of what? Now that's your question.
Isn't that a dictionary?
Yeah, because
Yeah.
this command here returns to me a dictionary. When I run this, I can safely assume that this is taking up the identity of what's returning back, which is going to be a dictionary. So if I wanted to grab the month, how would I change that in here?
Another
By-
bracket saying month?
Correct. Because I need to treat it as such. When this command runs, it's giving me this dictionary. So now I need to treat it as if I'm working with this specific dictionary here, and I'm gonna grab month.
Okay, so
And
you'll
now-
just specify that then
Right.
with a different set of brackets and basically chain them together.
Yeah. So remember, somebody asked, like, well, when I showed you guys that code snippet of that nested list, someone asked, "Hey, Roger, how would I call that list? Is there a variable name for it?" No. Its identity is that specific index. So you have to call that index first, and now you have access to it, and then you can treat it as such. right? So it doesn't have a variable name. If you want to access it or call it, you have to grab it by the index, or in this case, we're grabbing it by a key, which we now give it access to it, right? So yes, there we go. Now, we now get the month, which is 11. So we chain the keys as we dive deeper into our nested data structure. Awesome. Good questions. Good questions. So to add on to the question that was asked earlier, how do I update a key? Well, technically, you don't. You're going to want to remove that key and then reassign it. Let's say you created a key value pair, but you misspelled the word hello. You put one L. You're like, oh, this is bad. I probably shouldn't have this here. You're going to want to remove it and then update it to the new one. So how do we remove stuff? Well, you're going to use the del command for delete, or the del keyword, right? You say del for delete. You're going to call the dictionary that you're trying to access and the key you're trying to delete. And then when you print out this dictionary, world is currently Monday right now. They shouldn't return that anymore. We see here Monday is nowhere to be found, right? So after you delete it, you can kind of go back later on and then just reassign a new value to Monday. Make sense? Do you have any questions about key value pairs and dictionaries? Okay. So there's a couple of other methods that come with dictionaries. We have 3 methods, which if you come from JavaScript, this might look a little familiar. There are some small differences on one method, but we have 3 methods here. It's going to be the dot keys method, the dot values, and the dot items. The dot keys method is going to return to me a list-like object of all the keys. Now, I understand that it might be a little difficult to understand what it means by list-like object. Just it's going to look like a list, but it won't have the functionality of the list. So when I print this out, we'll see what it looks like. Print. And we see here, we get an object called dict keys. And inside this object, we see a list. And I see all the keys of hello, thank you, and goodbye. Just keys, no values. In the form of a list. Now, there's some things that you can't do with this. I think we can't do something like, I don't think I can do dot pop. Right? Dict keys object has no attribute pop. List let me do pop. Why doesn't this let me do pop? Because it's not an actual list, right? That's why it says list like object, because it's gonna give you what looks like to be a list, but you actually can't do all the methods that come with a list. But why is this helpful then, Roger? Why would we want to use this? Well, hypothetically speaking, let's say you find yourself in a situation, you need to look through all your keys to find if there's a key that exists. You could do that, right? You could call all the keys. I don't think we can save it to a value. Let me see. All keys is equal to English French dictionary dot keys. Print all keys. Yeah, I mean it worked. It's still a list like object, right? Is that a list? Let me see if I can convert it into a list. Actually, I've never tried this. It did. I can convert it to a list. Okay, that's cool. But this won't affect my original dictionary. So even though I convert it to a list and I do something like all keys dot pop, I can print all keys and I can also print English French dictionary dot keys, and this won't affect my original. Right? Hello, thank you. But hello, thank you, goodbye. So I removed the goodbye from the list of all keys that I had created. But this really just created a copy that's supposed to be a list type, but my original dictionary stayed the same. So as you can see, I can't manipulate the keys using the dot keys method. And when I say manipulate, let me rephrase that. I can't mutate it. I can't modify it. I can't delete or remove stuff by calling dot keys dot pop, right? So why is it helpful? It's helpful in events where I might want to do something like iterate through all the keys for key in English, French dot keys, French key. It's helpful this way because I can iterate through them and check them one at a time. And really that's where it matters, right? I can iterate through the keys and say if key is equal to hello, print the hello key is in this dictionary. Right, so I'm able to iterate through a list-like object of keys to see if a key exists in there. And if so, I can do something like print something out, right? So dot keys, these methods to receive list-like objects, although you can't manipulate the dictionary itself, it gives you an idea. It lets you visualize what's in there. So you know how to move forward, whether you should continue working with this dictionary or not, or if you can even access something. How do I increment the value number of a key in a dictionary? That's a good question. Very briefly, I'll talk about it. So here is, I'm creating a dict nums is equal to 1, this will be 500. 2 is going to be 1,000. 3 will be 1,500. Right? So I have key value pairs of values of 500, 1,000, 1,500. I can iterate through this and say something like for, actually I won't even iterate through it. I'm gonna say dict nums. I'm gonna grab the key of 2, and if I want to increment, just like JJ asked, I would say plus equals, and right now 2 is 1,000, so I can increase it by 500. And then let me go ahead and print it out again to see what it looks like. And we see that the value that's inside of key of 2 is now 1,500 as well. So you can assign stuff by using the equal sign, but you can also increase the value of something by saying plus equals. So it's going to grab the original value and it's going to add to it something that you're passing in. So that's how you would increase the value, JJ. JJ, I don't know why you changed your name, but it would be easier to call you by your first name if I knew it. I hope we're cool like that. I can call you JJ. Well, yeah. So, but that is how you increase the value. We'll get to that in a little bit, JJ. So, here is the keys. So the same way that we're able to grab a list-like object of keys, we can do the exact same thing for values, right? Here we see the values returns to me a list-like object of the values. Bonjour, salut, merci, and au revoir, right? Notice here's a value, the value, the value. So we can grab a list-like object of keys, a list-like object of values, or let's say we need both of them. We could say dot items. And this will return to me tuples inside of a list. And it's a tuple to show me the key and value pairs, right? Because it's multiple values I'm getting here. The first tuple is the first key value pair of hello with the values of bonjour and salute. The second key value pair is thank you with the value of merci. And then we have goodbye with au revoir. How do I increment the value of a key in a dictionary? Say I don't know what the actual value, but I know the key. How do I increment them then? Well, if you know the key, JJ, you would increment it the same way. I'm not quite sure exactly your question. It won't change how you increment. When you modify a value or you reassign a value, you do it the same way. You have to call the key first, and then you can access that value to change it. So I'm a little confused on exactly what you're trying to do. If you like, you can come on the mic and maybe explain your scenario, and I can give you a much better answer.
Yeah, so can you go down a little bit
Mhm.
back to the dictionary that you created with like 1, 2, 3
Oh, I'm sorry, I
key,
deleted it.
right?
Let me go ahead and add it here. We'll say dic nums is equal to 1,500, 2, 1,000, and 3, 1,500. Okay, go ahead.
Okay, so say I'm doing something funky, right? And I want to essentially increment the values of every single keys in the dicknums dictionary. But I don't know that 1 has a value of 500, 2 has a value of 1,000, and 3 has a value of 1,500. I just know, hey, this dicknums dictionary has these keys, and every single values in those keys should be incremented by 1.
Sure. Let me see if I can give you a good scenario of how this works. I'm going to go ahead and create a random name is equal to, I'm going to say Tamika. Is that how you pronounce your name? Okay, we'll do Tamika. Here we have um, Tamika's name. And I'm going to try to figure out how many letters she has in her name. And I want to increase my count if I've encountered that number before. I'm sorry, not the number. If I've ran into a letter in her name and it's already in my dictionary, then I need to increase my count, right? Because that means it's already some kind of track record of that letter in my dictionary. If when I run through this loop, the first time I encounter the T, if I've never encountered the letter T in her name, then I need to start a count in my dictionary. This is a very good scenario. So here is her name, Tamika, and we'll use her last name too for the sake of adding more letters here, Singleton. And I'm going to say letter count. Here's my dictionary, right? It's going to be an empty dictionary that I'm going to use to keep track of how many times I've encountered a letter in her name. So what I would do is I would iterate through her name first. So I will say for letter in random name. And I know we haven't gone through loops yet. Just bear with me if you've never seen this. But this allows me to go through every individual character in her name, and I can print out the letter, and we can see that work here. Right? I can grab every letter. So what I'm going to say is, if letter not in, and I can say letter count dot keys. I can do a membership check, right? Because it's a list-like item. Dot keys is going to return to me a list-like item. Although I can't remove things from it, I could use it to check what's inside of it, right? So we do something like a membership check, which has been covered in previous classes. I'm going to check if the letter I'm currently iterating through is currently in the keys of letter count. And if it's not, then I need to add it to the dictionary and set the count to 1 because I've encountered it for the first time. I would say letter count, and I would pass in the letter in here to save it as a key, and I'm going to save it to 1 because the first time I encountered it. If it is in here, that means this already is in letter count with some kind of value. It could be 1, it could be 2. But the point is, it's already in there. So instead of resetting it to 1, I'm going to increase it by 1. Right? So if I haven't encountered the letter, I'll start a new counter key value pair set to 1. If I have encountered it, I'm going to increase it by 1. And then at the very end, I can print out letter count. And I see here that the letter T, because she has a T in singleton and a T for her initial, her first name is 2. She has 1, 2, yeah, she has 2 A's. And you see here, I'm able to grab every single letter she has in her first and last name, and there's no repeats because the moment I found it, I increased the count instead, right? And there's one weird one here where there's like a space because there's a space in her name, right? Because when we iterate through a string, it's also going to check for the empty spaces. We could do a check for that to ignore it, but yeah, that's how that works. Does that answer your question, JJ?
Yes, thank you.
So in
Yeah,
this
so
example you made, obviously for every letter, it's essentially bypassing the if statement, running into the else statement because the letter count is empty.
no, because when this first starts, the first letter I'm gonna get is T. So it's not going to bypass the if statement because T in Tamika, the first letter, that's gonna be the first time I encounter it. So it's gonna run this, right? The next time I run
Got
into
you.
T in her last name, that's when it's gonna bypass it because T already exists. So instead of setting it to 1, I'm gonna go to the else statement and increase it by 1. Make sense?
Gotcha. Yeah, got it now. Thank you.
So would it be fair to say that the letter count data structure that you're using here is being used as a table to keep track of things?
Yeah, they typically call it like hash map. But yeah, it's like a table, right? It's like a score sheet. You're correct. That's a good way of thinking about dictionaries when using it as a counter. Any other questions? Awesome. Time is 8 p.m. Let's go ahead and take our last 10-minute break for the night, and I will see you guys at 8:10. Thank you. Welcome back, everybody. We're gonna go ahead and pick up from where we left off. So we were covering the dot keys, dot values, and we mentioned dot items. The only difference between JavaScript and Python when it comes to using these methods is in JavaScript, it's dot entries for the equivalent of dot items. So everything we have covered so far in regards to objects from JavaScript, right, and Python's dictionaries, everything's been the same, right? The same way that you access objects in JavaScript, that's how you access dictionaries in Python, right? Both from keys, how you add keys, in values, how you update key values, right? Removing it, I think it might be a little bit different. I don't remember off the top of my head. But for the most part, about 90% of this is pretty much the exact same. The next real difference is when using these specific methods like dot items in JavaScript, it's dot objects. So I'm sure for all my JavaScript people who went through the JavaScript course, you probably noticed already so many similarities compared to Python and JavaScript. If anything, you might notice Python is a little bit more, easier to understand. Some of the wording for some of these methods are a lot more straightforward, right? But kind of going back to what I mentioned day one, if you learn JavaScript, there's no issue learning Python. A lot of these languages especially high-level languages, they have very similar syntax, and it's very easy to pick up another one, which once again, it kind of builds upon to what I said before. Like, sometimes when you've been doing this for a while, learning a language can be a little boring because a lot of these concepts are the same. You're really just trying to learn how the wording is done so you know how to code in it. And it can be very, very boring sometimes. But let's go ahead and continue. So the other important dictionary method that you need to know, and the one that I would say is probably the most important one from all five of these by a long shot, it's going to be the very first one here, which is going to be the dot get method, right? The dot get method is one of the reasons why dictionaries are so good to use. In lists, when you want to grab something inside of a list, you either have to, one, know the index of it. You already need to know where it's at. Like, and it could be difficult, right? Because indexes are so abstract, right? It's just numbers, 0 through a million, however many items you have in a list. They could be anything, any value. If it's a list, a dictionary, a string, a whole sentence, you don't know where it could be, right? How is 5 supposed to tell me that's supposed to be Jose's email, right? How am I supposed to know that Jose's email is at index 5? There's nothing that shares any kind of relevance to it. So it's very abstract. Whereas dictionaries, you can assign it a unique key, right? That gives you an idea of what it is, right? Just like the driver's license. I was able to give it the key of DOB, which makes it very easy to understand and kind of memorize. So in case I need to find the date of birth, I can try to grab the key of DOB, right? Another big difference when accessing lists and dictionaries is if I don't know, and this is where it's very important, if I don't know the index for the list item I'm trying to grab, I have to go through every individual item until I find the item I'm looking for. And that's going to increase the computation of the computer of how many iterations it has to go through until it finds the value it's looking for. If I have a long list of emails and I'm trying to find Thomas's email, I would have to go from start to finish until I might find it. Maybe his email might be the very last one inside of that list, and it could take forever, right? Whereas dictionaries, we have the keys, or ideally, you could use the dot get method. And the dot get method is going to allow you to pass in the key that you're looking for, right? Because we have the ability to add a key that gives you a some kind of way to reference whose emails whose. For example, let's say if you worked in an environment that everyone had a specific identifier. Let's say to access someone's data inside this dictionary, you would get their initials and their last four, right? So I might get JM, last four could be like 0123. Right? So it would be easier to access someone's data if I had something like that. I could find Jose Medrano's information very quickly like that, whereas in a list would be very difficult. Now, the get method becomes very handy when you try to access a key value pair that doesn't exist. Take the English-French dictionary that we've been using. As it stands right now, the only keys we have is hello, thank you, and goodbye. What if I try to access a key of library? If I run this, I'm going to get an error, right? Returns an error when the key value doesn't exist. That's where the dot get method comes in handy. What the dot get method is going to do is it's going to return to me something even if it doesn't find it. Therefore, it's going to take care of the error for me. The errors are really bad because when you get an error in your Python code, it's going to stop everything. It's going to stop your entire code from running if you don't have a way to handle the error, right? So here, this line of code, if I try to print this out, there's no way for me to handle the situation that if for whatever reason this key didn't exist, right? So I get the error. The dot get method has a fallback that it resorts to in the event it doesn't find the key value pair that you are asking for. And that's automatically defined with a default, right? You don't have to pass in anything. It's going to return to you, I believe, 0 or none, one of those two. If I try this here, instead of using the key directly, I invoke the .get method, and I pass in the keyword of library. It returns to me none. Okay, so it is none. It's not a 0. But instead of giving me a error, it handled it. And I see a message there in chat. Could try catch help. No, you'll still get the error. I mean, yes, you still get the error, but the catch, you're technically handling it there, right? But we'll talk more about try catch angel, but you're on the right track with that. You definitely could, but your catch needs to still handle it in there. The error will still be erased. So really, you're still doing the same thing. You're just adding extra steps to it, right? So here I use the get method, and by default, it's going to return to none if it doesn't find it. All right. But at least it didn't give me the error. So if I would have ran this in a regular Python file, and I tried to access a dictionary that didn't exist, I wouldn't get this issue. Yes and no, Thomas. If you try to use the .get method on a specific level of your dictionary, it won't work. You have to nest your way inside of there, just like we've done before, where I had to change the indexes or the keys until I got to the level of where it's at. Then it would work. It's not just gonna bypass everything. So by default, it is set to none, but you're able to override this default and pass in your own personal response, right? So by default, it's going to be set to none. But we see here that second argument where initially we left it empty. This time we passed in not found. And when I run this, library still doesn't exist, but instead of sending me none, it's going to tell me not found. All right, so it lets me give a specific text. So it lets me know exactly what's going on. It makes it easier to debug in the event I need to handle this error. Right, so the document it, it's a great way to try to grab something in the event it doesn't exist. You probably want to use the .get method more normally as you progress through your career. You'll find yourself using the .get method for almost everything. You wouldn't normally access a dictionary just by the key itself because you run into that chance that it won't exist. So it's actually become very common practice to just use the .get method when trying to grab a key. All right. I think I already have this, but I'll run it again anyways. So that was the .get method. Dictionaries also have a .pop method, which can remove the item just like we saw before in other data structures. You pass in the key and it's going to remove that item, right? And it'll also give you the item back if you wanted to. Or a default value if the key is not present. So just like the .get method, it allows you to do it removes something if it exists. If not, it'll tell you none, right? Or you can pass it your custom message. So here's one way to remove something. In the event you try to delete a key that doesn't exist. You can also use pop item, which is going to remove the last item, I believe, of inside your dictionary. But it also lets you save the value just like the .pop. So they look they very similar, except this one takes a specific key, where this one is, I believe, it's a random one or it's the last one. I could try it out if you guys want to, but let's see.
Yes, please try it out.
Let's try it out here. Let me print out what English is before I do this. And then we'll also see what gets printed out. Print hello pot and English French dictionary. And this is supposed to be pop item. And we run this. So this is the initial dictionary, right? it removes what looked to be goodbye au revoir, which is the last item inside of there, right? So it looks like it removes the last item. So, but notice that we're able to save the item that we removed into a variable, right? The pop, as you notice, the common trend with pop, it allows you to not only remove, but get access to the item you removed to use it somewhere else. All right. We talked about get library not found. What else do we have here? Pop item update. All right. So we're going to create a new French dictionary, right? Notice this is a new English-French dictionary. We have the old one, which only has 2 items in here. We create a brand new one, which has some additional stuff. Notice that there is some repetitiveness here. Hello exists in the new ones, and hello is on the old one as well. And then we have a bunch of new ones here too. We can use the update method, which is very similar to the extend method, right? But as you see here, it will override older ones with the new ones. So be aware of that. But if you have a brand new other second dictionary that you want to use to update the original one, you could use a dot update method to do something like this. Just be aware that you will override older values. The old version had the list for hello, where the new one had just the word of bonjour, and we see that that was overridden. All right, but dot
reassignment.
Yeah, kind of like a reassignment with a more updated version. But additionally, unlike a reassignment, notice that the thank you stayed here, right? So not exactly like a reassignment because you are reassigning something new to it. Well, to be fair, let me rephrase that. When you reassign something, you delete what was there before, and then you create a new value and add it to it. This doesn't do that. You don't delete what was there before. You are essentially appending multiple items at one time into that dictionary. But we can't have duplicate keys, so anything that is duplicate gets overridden, right? So not exactly like a reassignment. The old are gone once that happens. No, the old are not gone, right? Thank you is still here, right? Thank you was in the old one. And notice that thank you is still there. It just extends. Once again, it's doing is appending new items. Um, just like we extended lists with additional items, that's all that we're doing here. We're just adding more additional items. The old ones are gone. Correct, right? Yes, you are correct with that, Angel. The old ones get overridden. So the old ones that if there were duplicates, they do get overridden and they're no longer present. They essentially they lose their address, right? Technically, for a brief moment, the string bonjour and salute that exists within this list, they technically still exist somewhere in your memory, but they no longer have a key or really an address that they're linked to. Because that's really what the keys are. They're a way to access your values that are saved in memory, right? But because they no longer have a key that's assigned to them, this key gets reassigned to the string of bonjour. This list goes to garbage collection and gets deleted from memory later on. So it loses its key, and that key gets reassigned to something else.
Would there be a way to update the hello to also include salute? Would you just have to like reverse which one you do the update on?
Yeah, well, there's no reversing. If you update it, you update it. It's gone. So make sure whenever you're updating, um, if there's a new value for something, then that means the new updated version needs to have the new updated version in there. Just like thank you still has merci to ensure that the old one doesn't get overridden, you have to make sure that's in there.
Well, like for the example, like instead of doing the English-French dictionary dot update, would it include the salute if you did the new English-French dictionary dot update with the other one as the argument?
Will they include? It's going to add. Sorry, I was coughing. Yeah, in that case, um, because bonjour and salute, this list is coming into the new one, then yes, this will get overridden, and we will now have bonjour and salute instead. So yeah, if you do it the other way around, that would work.
Gotcha. Okay.
Here we're just accessing, we seeing the difference. Here we go. We're popping hello. We're not saving it anywhere. Hello is no longer present, as we mentioned before. If I try to use the .get method on there, I can see it not found. So I'm handling the error because it no longer exists. We can pop an item just like I demonstrated earlier, and I can see which one it popped, and it popped the chicken and pullet. I think that's how you pronounce it. It looks to be like the last one on this list. Do you have any other questions about any of these methods with dictionaries? All right. So we've seen a couple of some operators that we've used before, right? We've seen max, min, and sum. You can still use these operators with dictionaries, right? You are able to pass in, for example, this example, we have set, and they're calling them max for sets. Now I'm not gonna lie to you, off the top of my head, I don't know if it's going to prioritize numbers or letters first. Let's check it out. It looks like it prioritized the 16, right? And even though 16 is not the highest number, I see 17 here. I think it prioritized the fact that Z was the first characters in these strings are alphabet letters, so it probably represented the order of priority in the ASCII values for the letters. That's how I use the max setting on this. So just be aware of that, and we'll see the same thing with the min. We'll probably grab A first. Yeah, A 18, right? So we're able to use max and min on this. Even sum here, we saw sum before already. Here's a list. They're using the sum method. This is going to grab every single item in here. It's going to add them up together and return to you the sum of all these values. So some min and max are great tools to have in your back pocket. These are something you might use very commonly. There's no reason why you should be hard coding. You iterating through every single item, finding the minimum value, saving to a temporary variable until you iterate through everything. There's already built-in methods to use. We can use length as well. Like here's an example of using length. We can see how long a dictionary is. This is going to tell us how many key value pairs we have within here, which is 10. One thing that we didn't see was, can we use max and min for my dict? And here, the max was J. So J was the max. The value was 9. And I get min. I want to make sure it's grabbing the Q or the value. Let's say min. Okay, min gave me a. So I can see here from using max and min, it's returning to me the max and minimum of the values. Oh, actually, it's a little misleading. Let's put 50 or 45 or 50 here. Yeah, okay, it's gonna give me the min of the letters, so the keys. So using min and max on dictionaries is going to prioritize the keys, but I might be able to override this by saying dot values. And for the values, there we go. We're now getting 1. So by default, if I use a method like min, max, or sum, and I don't specify whether I want to get the max or if I don't want to get the values of the keys, it's going to default to keys. So when using min, max, or even sum, if you want to specify values, you have to say values. If not, it'll default to the max, min, and sum of your keys. So just be aware of that. We've seen sorted as well. We can also sort right? Notice here we're sorting my dict in reverse order. And it returns to me a sorted list of keys, right? A sorted list of keys. I could probably do dot values as well. And it'll return to me a sorted list of values, right? So once again, by default, it will stick to keys. Unless you want values, you have to specify values. Do I have any questions on using operators like min, max, sum, sorted on stuff like sets or dictionaries?
Kind of like a backtracking question, but we just did a sorted example. For sorted, do you need to print those, or is that not required being printed? I know
Yes.
the whole thing with Jupyter Notebook.
Once again, it still applies, David. The same concept with Jupyter Notebooks is it's still gonna print out for me no matter what I do. So I do want to do print common practice. I was just getting lazy because we are getting to the end of the class. I
Yeah,
apologize.
no,
But
you're
yes.
good. I just want to know if sorted was a special case or not.
There's nothing that your Python file will print out unless you specify prints. All these print statements are happy no matter if it's dictionaries, lists, whether I'm using sorted. Nothing will print out normally or naturally in Python if you don't call print. It's just Jupyter Notebooks being Jupyter Notebooks, right? Nothing. You have to call print if you want something to print. Jupyter Notebooks is just Jupyter Notebooks. I hate it, but it's good for teaching and showing you code blocks as I teach. All right. So that's going to conclude today's lesson for sets, dictionaries, ordered data structures in general. Once again, specifically dictionaries. These are very important concepts to know for your lab technical assessment because you're going to be expected to know how to create them, how to access them, and how to manipulate them, right? In what manner? Don't be surprised if you find yourself in a situation where you have to use dictionaries the same way that I used for the example of getting the characters of Tamika's name. This is a common way of using dictionaries, right? Dictionaries are very common to keep track of counts, or structuring data. This is a very common way of doing it. Updating and setting values to keep track of what your code is doing is a very common way. I wouldn't be surprised if the question you're asked for is probably something very similar to this, using dictionaries to manipulate and set values instead of dictionaries. I might just giving you the answer to a test. I'm not even gonna lie to you. I'm sorry, excuse me. I thought I muted myself. But yeah, so make sure you guys understand how to create dictionaries, how to access them, how to modify them, and how you can use them in your code, right? Up to this point, you guys have learned multiple data structures, right? List, tuples, sets, dictionaries. When should you use one or another? I probably wouldn't want to use a list if I'm trying to keep count of how many times the characters appear in a string, right? Because I wouldn't have a way. I mean, I could probably create a list of lists, right? I could probably do something like like I could say something like, you know, letter count where I have a list and the first one could be T, like a string of T, and the second index or index one could be an integer, right? The next one could be the next letter I found with the value index one being the count. But this becomes very annoying to work with because now the next time every time I'm updating the count, I would have to iterate through every single item in this list. And then once I grab each list, I have to grab index 0 to check if it matches the letter I'm checking. And if it matches the letter, then I have to grab index 1 to update that one. So it becomes more coding sensitive. I'm having to do extra steps. So that's when I find myself in a situation. Maybe I probably want to use dictionaries instead of lists because they natively have a way where I can pair two things together and access them a lot easier, right? I can use stuff like the dot get method instead of having to iterate through every single item. All right. So that's a situation where I might choose a dictionary over a list. So which, as you saw there, which data structure you use really it doesn't really matter. You could probably do the same thing with both. One will be easier to work with over the other. So it depends what kind of headache you want to go through when doing this. One is going to give you a much easier time coming up with an answer than another one. Um, and also, although we're not talking about it right now because it's a little out of scope for you guys, um, if I'm doing something like this, it is more efficient code-wise to use a dictionary than to use a list. So be aware of that for the future when you guys start thinking about how efficient my code is. Realistically, when working with dictionaries, because you have that key is an address. You don't have to go through every individual item to find something. You call the key and it takes you straight to where it's at. If it doesn't have the address, it's going to tell you none, right? Whereas a list, you have to iterate through every single one until you find it. So under the hood, dictionaries are actually more efficient when it comes to working with data. So you don't have to worry about that right now. I just wanted to make sure that you're aware of the capabilities of both dictionaries and lists. I heard a mic, so I'm assuming someone has a question.
Yeah, Roger. Actually, I was looking at the max my set, min my set, right? The
Okay.
in the syntax and the common operations. So I was curious about if it was like a mix of letters and numbers, what it would return. And then I took out all of the letters, and I accidentally actually took out a one on one of the series of numbers. So, for instance, in the string that I'm currently looking at, the F15 was turned into just 5, and then everything else was just missing the letter. And then I ran it, and it returned to me 5, which is not the maximum number in that listing. Why did that happen?
Does F15 still have the letter F, but everything else doesn't?
Nope. You
So
take out all the letters, and then any one of the first digits, whether it's the by the looks of it, all of them are 1 or the 0. So take out any one of the first digits, and it just returns a single digit number instead of the 2-digit numbers. Any
like
one
this?
of the just like that. And then hit run.
Nope. What do I do?
I don't know.
What do I do?
It
There we go. My bad. And it returns to 5. The max set here.
and the max there is, 19 if you look at that.
Sure. Let's look at the ASCII table.
So I don't know why. That's throwing me off.
That's okay.
Is it because it's not looking at it as a integer, or does that matter?
I think there might be a play into the fact that it's a string for now.
The original one that I hit was one of the 17s, so it returned only a 7, and then I was like, okay, well maybe it's just a fluke, and I deleted the first one, which turned it into a 5, and I ran it, and it returned back 5, which is not the max number. So I was just like, okay, that doesn't make sense.
I'm thinking that it put the 5s in the 10th place, not in the 1. So it makes it to where 5 is greater than 1.
I'm getting confused about different comments. What do you mean?
Yeah, so you have a 10th and a 1's place with 17. 1 being in the 10th place and 7 being in the single digits or 1's.
Okay.
So by it being a single 5, is looking at it as a 5 being the biggest number because there is.
I think what just happened here, let's see, we'll say 5 here, and then let's convert this one to 50. I think so it goes through, and because the first one has 1 value, it's going to compare that first value to all of these, right? 5 is greater than every first character in all the strings, except this one. This one has 5 for its first one. So now it's comparing these two. Okay, well, this is a single value, and now this is 2 values. This one has a 0. So this is 50 is greater than 5. And then that's when it prioritized this one instead. I think it's because it's comparing the first value for now.
So it's not necessarily looking for the maximum value of the entire thing. It's looking at the maximum value for the first digit sequence, whatever you want to end up wanting to call it, through that entire string.
Yes, and I think it's because it's working like that because there's strings. If there weren't strings, this should give you a different response. And we see that here if I remove all these strings and I turn this back to a 0, I think this was 0, 0. Now I'm getting 19 instead. I think you see that weird functionality because it's working with strings. So when it starts working with strings, it's gonna start with the first value. Yeah, I think that's what it is.
Now, could you turn that set into, like, you know how we did for list is, make it a float and then say max or min
I
at that
cannot.
value?
You can. Are you saying like this?
Yeah, kind of like how we did for, like, you do float my set
N-
and then you'll do max my set.
no, you
So like
cannot.
the
You
because it's
cannot
not a
bypass.
variable, right? Okay, gotcha.
Not because it's not a variable. It's because it's an iterable. That's the biggest thing. There's a
Okay,
lot of values in here, and it doesn't know how to handle multiple values.
okay.
Typecasting, you're gonna pass in one value at a time. So if I wanted to convert all of these into floats, I would have to iterate through them for num and my sets. Um,
Okay, gotcha.
Num is equal to float num. And then I would have to create a different set. Formatted set is equal to, I'll say formatted num. And then I will say formatted sets dot add formatted num.
Okay.
Right? So because it's an iterable, I cannot just pass in the wrapper of float and expect it to convert all of it into float because it doesn't know how to handle so many numbers at a time. You have to go one by one, convert that individual number into a different variable that's now a formatted float version of it, and then you're going to save it to a different formatted set variable. This is how you would do that. Does that answer your question, Jose?
You execute that.
It is. Yeah.
Can I execute this? Yes. Let me print it out actually. Print formatted set. And I'm gonna remove this wrapper here because this will give you an error. Formatted set dot add. Dict object has no attribute add. This is a set. What are you talking about? Hold on, stand by. It's telling me it's a dictionary, but it's a set.
You have to return it.
I don't have to return it because it's not a function. All right, if it was a function, I would return it, but I'm just doing the
Yeah.
code here.
Gotcha.
So here is my sets. I have individual numbers.
Didn't you create a dictionary there with formatted set?
I did. You're right. See, yo, you're on it. Okay, there we go. That's a good catch. Good catch. There we go. Yo, whoever caught that, yo, good on y'all. It shows me you pay attention during class. But there you go. So you would have to write it into a different set, and now you can see here these are floats.
What was the issue
Gotcha.
that I think Thomas pointed out?
Yeah, so as I mentioned to you guys before, when you create an empty set, you have to use the set keyword because it's going to default to a dictionary when using curly braces. So I have to specify that formatted set was an empty set by using the set keyword. I try to do a set with curly braces, and when I try to add things to it like a set using the set method of add, it did not work because it was a dictionary. Make sense?
Yeah, gotcha. Because add is a set method, not
Method.
a yeah.
Correct. Any other questions?
No, I appreciate it. Thank you.
Awesome.
Good class. Good
Yeah,
class.
thank you very much.
All right. Well, that's going to conclude today's class. Before, who does not see this in their assignments? Raise your hand in Zoom. You could just react. Raise your hand. Okay, good. I only asked that because I recently made this change. I don't remember if I made it before class started. There used to be some links here that went to other problems, but they were broken. So I had to manually create 4 new problems so you guys can practice those methods and creating dictionaries. But all right, that's gonna conclude today's class. I'm gonna go ahead and stop the recording now.